This video will discuss the solution to question 31. Figure 6 shows a particular dynamic memory implementation with CS is 10 femtofarads, CB is 100 femtofarads and VDD is 1 volt. What is approximately the readout voltage at node X for a stored 1 just before the sense amplifier is activated? And then 8 possible voltages are given. Now this here is figure 6 and we're going to find the voltage at this node. This here is node X. We can recognize the memory cell over here, that's on top. It reads cell and it contains these storage capacitors, CS. Below it we have a differential sense amplifier which consists of a latch which looks like this. And at the bottom we have a pre-charge circuit. Now to find out what the voltage will be at node X, we need to look at the state of this capacitor CB and CS. So before this access transistor is opened, the circuit looks like this. So we have two capacitors with an open circuit between them. From this we can actually compute the charge which is stored on each and every capacitor. So the charge that's stored on this storage capacitor is CS, that is 10 femtofarad from the question, and we store the value 1 in this dynamic memory cell, and that's equivalent to storing a voltage of 1 volt, or in other words VDD, on there. From that we get that this capacitor stores 10 femtocoulombs of charge on it. We can do the same thing for CB. The important thing to remember about CB is that the line to which it has been connected, which is this one, is pre-charged to a voltage of VDD over 2. So that will give us the following. So in total we have 100 femtofarads of capacitance multiplied by 0.5 volts of voltage, and that gives us 50 femtocoulombs. So this is the state of the circuit before this transistor is turned on. When the transistor is turned on, we get a connection between these two capacitors. And that means that this charge will actually redistribute in some way. We can now think of these two capacitors as one big parallel capacitor. So this will be the total capacitance and it will store a certain voltage across it. And because charge cannot spontaneously be generated or disappear, we know that the amount of charge that's stored on this total capacitor will actually be the same as in the before state. We can now compute the voltage across this total capacitance as follows. The total charge is this 10 femtocoulombs plus 50 femtocoulombs, and that gives us 60 femtocoulombs in total. And the total capacitance of these two parallel capacitors is just the sum of their individual capacitances. So that's 10 femtofarads plus 100 femtofarads is 110 femtofarads. So that gives us 545 millivolts across this total capacitor.